So when you're asked to factor a higher order polynomial, it's not possible to start with regular factoring because we have a higher degree polynomial, higher than 2, and we also don't have a common factor that we can pull out. So when we're asked to solve something like f at x, where f at x is x cubed plus 3x squared minus 9x plus 5, you'll notice that the degree is 3, that there is no common factor, so there is no x that we can pull out of each term, for example. So what we really need to do is put together all of the polynomial long division, remainder, and factor theorem knowledge that we have and put that all together to factor it. So the first thing we need to do is figure out what is a factor of this. Is there a factor that can divide into this evenly? So that's using the factor theorem. So what you want to do is you want to take this positive 5 and think about the different factors that multiply to positive 5. So of course we can use positive 1, positive 5, negative 1, negative 5. And so I'm just going to pick 1 to start with. If I put f at 1, x equals 1 in, we've got 1 cubed plus 3 times 1 squared minus 9 times 1 plus 5. So we end up with 1 plus 3 minus 9 plus 5, and 4 minus 9 plus 5. That comes out to 0. So we are in luck. We just figured out that our first factor is x minus 1. You may have picked a different factor, and that's okay. But we can only say that x minus 1 is a factor because f at 1 was equal to 0. So that's using the factor theorem. And we only need 1 to start. So if x minus 1 is a factor, the next thing I want to do is look at using polynomial long division to divide x cubed plus 3x squared minus 9x plus 5 by its factor x minus 1. And again, if you're using synthetic division, as long as you're showing your work with that, that's perfectly fine. But I just use log division to divide. So I'm going to divide x minus 1 into x cubed plus 3x squared minus 9x plus 5. I'm going to start by taking the leading term in the dividend and divide by the leading term in the divisor. So x cubed divided by x gives us x squared, and I'm going to put that in the x squared spot. The next step is to multiply x squared by x minus 1. So I would obtain x cubed minus x squared, and I'm going to subtract. So I end up, of course, with 0x cubed plus 4x squared, because I'm doing 3 subtract negative 1x squareds. And I bring down the next term, which is negative 9x. And the whole process starts again. So how many times does x, the leading term in the divisor, divide into 4x squared? Well, it goes in positive 4x times, making sure to line up the x term in the quotient with the x term in the dividend. 4x times x minus 1 is 4x squared minus 4x. We subtract, so the x squared terms are gone. We get 0x squared. Negative 9 plus 4 gives us negative 5x, and we bring down the positive 5. And the last time, we're going through the same process. X goes into negative 5x, negative 5 times. So when we multiply negative 5 by x minus 1, we end up with negative 5x plus 5. We subtract, our remainder is 0. And that's what should happen if you have correctly found a factor. If you haven't, then go back and check your remainder theorem calculation just to make sure you're doing that properly. Okay, so the next thing that we need to do is look and see what our factors are and see if any of them can be broken down further. So we know x minus 1 is our first factor. And our next factor can be found by looking at x squared plus 4x minus 5. So we know that that times x minus 1 equals 0. That is what we're trying to solve. So we're trying to, again, find those x-intercepts on our graph. And we can break down x squared plus 4x minus 5 with simple factoring. X plus 5 and x minus 1 should work, I believe. And so we end up actually with a nice double root. So x minus 1 all squared times x plus 5 is our fully factored form of our polynomial, of our polynomial there. So we end up with a couple of different roots. We end up with x equals -5. So -5, 0 is that first x-intercept, or 0. And x equals 1 is an x-intercept as well, but it's also special. When you have a double root or a triple root, what that means is that at that value, x equals 1, you also have a turning point. So 1, 0 is a vertex as well as an x-intercept, which is kind of interesting. And that's going to help you start to create your graph.